Assalamu alaikum. In the previous lecture, we discussed definitions of trigonometric ratios, six trigonometric ratios are there, and the definitions of the trigonometric ratios in terms of right triangles we have discussed it last time. The six trigonometric ratios with respect to acute angle A are sine A, cos A, tan A, cot A, sec A, and cosec A. Let us go through the definitions quickly to recollect what we did yesterday. A statement was given to you which helps us to remember the definitions of first three trigonometric ratios, consisting of 9 words divided in 3 groups of 3 words each. In each group, first word, first alphabet represents trigonometric ratio. First alphabet of second word represents the numerator of the ratio. First alphabet of the third word represents the denominator of the ratio. Thus, we have sine A as perpendicular by hypotenuse. The definition of sine. Acute angle is A. Cos A is defined as base by hypotenuse. Tan A is defined as perpendicular by base. These three definitions we get from that statement. In the statement we have some people have sine perpendicular hypotenuse. Curly black hair, cos, base and hypotenuse. First alphabets. Tan A is perpendicular by base. Statement has to present beauty. To for tan, present, P for perpendicular, beauty, B for base. And about the remaining 3 you were told these are the reciprocals of the first 3. Cot is the reciprocal of tan. Sec is the reciprocal of cos. Cosec is the reciprocal of sine. Thus, we have cot A as base by perpendicular. The reciprocal of tan. Tan is perpendicular by base. Reciprocal is base by perpendicular. Sec is hypotenuse by base. It is reciprocal of cos. Cos is base by hypotenuse. Its reciprocal will be hypotenuse by base. Cosec is hypotenuse by perpendicular. It is reciprocal of sine. Sine is perpendicular by hypotenuse. So the reciprocal will be hypotenuse by perpendicular. And then we applied this to the right triangle. If we have ABC a right triangle, right angle that B, then with respect to acute angle A, we were told yesterday, AB will be the base, adjacent side we call it yesterday. BC will be the perpendicular. It is the opposite side of the acute angle chosen. AC being the hypotenuse. Side opposite to right angle, 90-degree angle. And therefore sine A will become perpendicular by hypotenuse means BC by AC. Cos A, which is base by hypotenuse, will become AB by AC. Tan A, which is perpendicular by base, will become BC by AB. Cot A, which is base by perpendicular, will become AB by BC. Sec A, which is hypotenuse by base, will become AC by AB. And cosec A, which is hypotenuse by perpendicular, will become AC by BC. All this we discussed yesterday. And then you can see the basic property of numbers also is applicable, is fulfilled. You have read in numbers, when a number is multiplied by its reciprocal, the product is always equal to 1. Therefore, sine A multiplied by cosec A will be equal to 1. Likewise, cos A multiplied by sec A will also be equal to 1. Tan A multiplied by cot A is also equal to 1. The results can be verified also. For verification, you have to use the right triangle, apply the definitions of the trigonometric ratios involved in the different results. You will verify it. Let us verify the first one. Sine A into cosec A is equal to 1. To verify it, let us use the definition of sine A and cosec A. By definition, what is sine A? Sine A is perpendicular by hypotenuse. What is the name of the perpendicular in the figure? BC. Hypotenuse is AC, so it is BC by AC. Then the definition of cosec A. Cosec A is hypotenuse by perpendicular. Identify their names in the figure. Hypotenuse is AC, perpendicular is BC, so it will be AC by BC. And then when we use these in the result, sine A multiplied by cosec A will be then equal to, for sine A we'll write BC by AC, multiplied by, for cosec A we'll write AC by BC. Well, as we multiply them, AC will cancel with AC, BC will cancel with BC. What is left? It is 1. That proves this result. And the remaining 2 can also be proved correspondingly. Now with this recollection of what we did yesterday, let us begin the exercise. Remember, this exercise is purely based on definition. You have to use definition in all the questions. All the questions will be solved by using definitions. Question number 1. It is exercise 6.8.1 of your textbook. I have the exercise number from the old book. From your new books, you will correspondingly see what is the number. Question number 1. In triangle ABC, right angled at B, AB is 24 centimeter, BC is 7 centimeter. You have to determine sine A, cos A, sine C, and cos C. Well, in all the questions, you will have to begin with drawing the diagram. The diagram will always be of that of a right triangle. We were yesterday told that in this class we will be restricting ourselves to the right triangles only, though the trigonometric ratios can be applied to all the types of triangles. But here at the introductory level in this class, we will be restricting ourselves to right triangle only. Therefore, in all the questions, whichever question you will come across, you will have to draw the right triangle. The name of the triangle is ABC as per the statement. It is given that it is right angled at B. So this vertex will be B because it is the right angle. ABC is the name of the triangle. The remaining vertices will be then given the names A and C. We are given AB is 24 centimeter and BC is 7 centimeter. This is a rough figure. Therefore, it is not drawn to the scale. Out of the three sides of this right triangle, we have the measures of two sides only. The third side is not known. In order to find the trigonometric ratios which are required, this will be the common procedure of all the questions before using the definitions of the different trigonometric ratios involved in the question. You need to find the measures of all the three sides. And presently in this question we know measurements of only two sides. Third side is not known. Therefore, you cannot directly go to the definition part of the questions to find the required trigonometric ratios. You will have to begin with finding the measurement of unknown side, the third side here. And remember, this third side in all these questions we will find by applying Pythagoras theorem, because the triangle involved is a right triangle. We'll be applying Pythagoras theorem to find the third side, which states that square of hypotenuse is equal to the sum of the squares of the other two sides. In this triangle, which is right angled at B, AC is the hypotenuse, so square of AC will be equal to the sum of the squares of the other two sides. The other two sides here are AB and BC. Sum of their squares, square of AB, square of BC, their sum will be equal to the square of AC. So we'll be applying Pythagoras theorem to find first the third side AC. So we'll have AC square is equal to AB square plus BC square. In the bracket you will write Pythagoras theorem. And then to find the measurement of this third side, let us put in the known values. AB we know, BC we know. So it will be AC square is equal to 24 square plus 7 square, which will further become AC square is equal to 576. 24 square of 24 is 576 plus 49. Square of 7 is 49. Then you add them, 625. To find the measurement of AC, the length of AC side, you will have to convert this 625 to square. And you know 625 is the square of 25. Why we made the square of this? So that we can remove square from both sides to get the measurement of AC. As you cancel square from both sides, we'll get AC is equal to 25 centimeters. This is our third side. And the procedure will be applied in all the questions that will follow. Before you start using the definitions of required trigonometric ratios, the trigonometric ratios which are required there, you will have to make sure that you know the lengths of all the three sides. Since in this question, lengths of only two sides were known, therefore, we found the third side, length of third side, by applying Pythagoras theorem. Now, knowing the lengths of all the three sides, we will now find what is required. In the first part of the question, number 1, we are asked to determine first part, sine A, and you have comma there, cos A. You have to find the value of sine A and cos A. Let us first find sine A. How will we find? To find sine A, we will use the definition of sine. So definition of sine with respect to acute angle A. Definition of sine you can get from that statement. First part of the statement, 3 words, some people have. To remember the definition, you have to remember that statement. Statement, first part of the statement is some people have, that gives us the definition of sine. First alphabet of each word in that group you have to use. Some gives us sine, people gives us perpendicular, have gives us hypotenuse. Therefore, sine is perpendicular by hypotenuse. Next, we'll identify their names from this figure. Definition we have used. Now we'll identify these in the figure. And for identifying perpendicular and base, you were told yesterday, remember, you have to apply it time and again. Perpendicular and base, identification of these depends on the acute angle that you have chosen. There are 2 acute angles in the right triangle. In this right triangle, we have A as acute angle, C as acute angle. You have to choose one of them. And the choice is as per the statement here. Angle involved, acute angle involved here is A. Sine A it is. A is the acute angle. So, you need not choose acute angle of your own choice. It is already stated in the question which acute angle you have to use. You have to use A as acute angle here. And with respect to A, you can refer to the figure and identify the perpendicular. Perpendicular is the side opposite to the acute angle. Acute angle being A, side opposite to that is BC. So therefore, perpendicular is BC divided by hypotenuse is the side opposite to right angle, and it is AC in the figure. Thus, sine A is BC by AC. Now use their values. We know BC is 7, AC is 25. It is 7 by 25. That is sine A. You have to find next cos A. Same procedure you have to use. Previously we used definition of sine. Now you have to use definition of cos. And then you have to use acute angle A to identify the sides. By definition we mean by cos, base by hypotenuse. This definition we get from the second part of that statement. Second group, 3 words, curly black here, cos, base, hypotenuse. Base by hypotenuse. Cos is base by hypotenuse. Now identify base again with respect to the acute angle involved in this statement. A is the acute angle. With respect to A, base is AB. Thus it is AB divided by hypotenuse is again AC. Cos A is therefore AB by AC. Use the value. AB is 24 divided by AC is 25. So we have found sine A as well as cos A. Second part of this question, we are asked to find sine C. This time acute angle is changed. Instead of A it is C. We also have to find cos C. So therefore, definitions used will be same. For sine it is perpendicular by hypotenuse. For cos it is base by hypotenuse. But you have to identify them now with respect to acute angle C. Sine C let us find first. Definition is perpendicular by hypotenuse for sine. Now identify perpendicular. Remember, hypotenuse will not change. opposite to a 90-degree angle, we have AC. So the denominator will be again AC. But the numerator will change now. With respect to C acute angle, now you have to decide perpendicular. Opposite to C is AB side. Thus, it will be AB by AC. It will be 24 by 25. Sine C is 24 by 25. What about cos C? Definition is base by hypotenuse. Now identify base this time with respect to acute angle C. Which side will call base? BC is the base, adjacent to acute angle. Yesterday you were explained. BC by AC, it will be therefore cos C, which becomes 7 by 25. That is cos C. Same procedure will be using in the rest of the questions also. After question number 1, let us now solve second question. Question number 2. According to the statement, a figure is given there on your textbook. We find a triangle PQR, right angled at Q, involved. Right angled at Q, in which PQ is 12 centimeter and PR is 13 centimeter. Again, like previous question, measures of lengths of two sides are given to us. Third side is not known. Before we use the definitions of the different trigonometric ratios required in the question, we would like to find the measurement of third side, length of third side. And as I said in the previous question, to find the measurement of third side, the length of the third side, we will be applying Pythagoras theorem. So again, Pythagoras theorem will be applied. According to which hypotenuse square, what is the name of the hypotenuse here? It is PR, opposite to the right angle, is PR. So PR square will be equal to the sum of the squares of the other two sides. The other two sides in the right triangle are PQ and QR. Their sum of squares you have to take. So according to Pythagoras theorem, we have PR square is equal to PQ square plus QR square. This is Pythagoras theorem. And then using this, you can find the length of the third side, because two of them we know. Put in the values. PR is 13, so it is square of 13 is equal to PQ is 12. We'll have square of 12 plus QR we do not know. Square of QR will remain as it is. Simplifying to get the measurement, 169 is 144 plus QR square. To solve this further, you will have to transpose this 144 to isolate QR. We have to find QR. It should be isolated first. 144 will be transposed. 169 minus 144 is equal to QR square. Subtract these. 25 is equal to QR square. And then to get QR, you have to remove the square. To remove that square, you have to change this LHS also to square. Square of 5, you know, is 25. Actually, it is square of plus 5 as well as minus 5. But we opt for only plus number here. In the chapter on quadratic equations, you have used both plus sign as well as minus sign. But here we use only plus sign because the length of the side can never be negative. QR is the length of side, and the length of side can never be negative. That is why we don't use that minus sign. We use only plus number. Removing squares on both sides, we'll get the measurement of third side QR equal to 5 centimeters. This is the third side. Same procedure, we did same thing in the previous question also. Third side we found by applying Pythagoras theorem. And then using these three sides, we will now find, as per the statement, we have to find tan P minus cot R. Therefore, tan P minus cot R is equal to find this, we'll use the definitions of tan and cot and then put their values. By definition, tan means perpendicular by base. To present beauty is the definition of tan. Tan is perpendicular by base. Now tan P with respect to acute angle P, I have to choose the perpendicular and base. Perpendicular with respect to P is QR, opposite side. Base is PQ, so it is QR by PQ for tan P. Minus, likewise cot. Cot we know is reciprocal of tan. Cot, tan being perpendicular by base, cot will be base by perpendicular. Now, will it be therefore PQ by QR? No. We have chosen QR and PQ, perpendicular and base here with respect to which acute angle? P was the acute angle. Now the acute angle has changed. This time R is the acute angle. You have to decide, you have to choose perpendicular and base with respect to acute angle R. And with respect to acute angle R, base is QR, perpendicular is PQ. Therefore you have to use QR as base, PQ as perpendicular, cot is base by perpendicular, it is QR by PQ. QR by PQ. Use their values. QR is 5 divided by PQ is 12 minus again 5 by 12. Both of these will cancel. The result is 0. That completes question number 2, and that will do for this day.